formula. Now, empirical formula is the existence of molecules in the simplest ratio when you have the component elements interacting. For instance, you have water. Water is composed of 2 atoms of hydrogen and 1 atom of oxygen. So this is how we can compare the formula with the compound, which is water. So this formula here is empirical formula for water. The simplest ratio of the components is 2 atoms of hydrogen reacting with 1 atom of oxygen. Now, the molecular formula for water is the whole number that water can exist, or the existence of water in its whole number form. So which means in terms of molecular formula, I can say that water, which is H2O, is also H2O. So if I want to have more of molecular formula of water, then I can have 2H2O, 3H2O, and the rest. Why? Because molecular formula is concerned with the whole number of your empirical formula. In the same way, we have it for hydrogen peroxide, which is HO. The simplest ratio we can have to find or form the composition of hydrogen peroxide is 1 atom of hydrogen reacting with 1 atom of oxygen, which is HO. Now, the molecular formula of hydrogen peroxide has to be H2O2, which is the correct formula for hydrogen peroxide. So this N stands for 2. So if you open the bracket, you have 2 times H and 2 times O. So you have H2O2. Likewise, benzene. The simplest ratio that benzene exists is you have equal number of carbon forming a component with equal number of hydrogen atom. So you have C6H6. So the simplest form is your empirical formula, which is CH. But the empirical formula, which is CH, is not the true formula for benzene. That is just the existence in the simplest form. The true formula is C6H6. Find the empirical formula of a compound. Yes. Which on analysis use the following as the reacting masses. Yes. Carbon takes 2.0 gram. Yes. Hydrogen is equal to 0.34 gram. And oxygen is equal to 2.67 gram. Good. Now we are to look for the empirical formula and what? The molecular formula. That's not all about the statement you have in the question. Yes? From your results. Find the molecular formula of the compound. Yes. The relative molecular mass of these compounds or these atoms on analysis is what? 60. Now, I want you all to look up. Anytime you want to solve this, it's not hard. Just like the way they gave you. Just write carbon, hydrogen, and oxygen. Okay, you have been given the mass number of these atoms to be what? Carbon is 12, hydrogen is 1, and oxygen is 16. Thank you. Now, the next thing to do is you find the number of mole of each of the atom. How do we calculate number of mole of an atom? It's very simple. Number of mole of any atom is simply equal to the relative or given mass over mass number over what? Mass number. That is how to determine the number of mole of what? Of an element. Another formula is the number of atoms of such element divided by Avogadro's constant. But we are not going there. This is what we want and this is what we need. That number of mole of an element X is simply what? The relative or given mass. Then mass number. What's the difference between relative mass and mass number? Relative mass is when they tell you that the carbon I'm giving you is 30 grams, is 20 grams, is 5 grams, is 11 grams. So that gram, that mass is called what? Relative mass or what? Given mass. Do you understand? But carbon as it is, its mass number is what? Is 12. Is what? 12. Do you understand? So when we say we want to find the mole of this, this, and this, what are we trying to do? This is it. We are going to say number of mole will be what? What is the relative mass? That is the given mass of carbon. Is 2.0 divided by what? What is the molar mass? Sorry, I said molar mass. The mass number of carbon. 12. Do you understand? Good. So what about hydrogen? 0.34 divided by what? Over 1. Then oxygen is what? 2.67 over 16. Now I want you all to compute this and tell me the results. So when you have 2.0 divided by 12, what do you have as your result? 0. What?
167.
167. But let's get our result in 2 decimal places. So 0. What? 17. Then this remains what? 0.34. And then this is what? 0.17. Thank you. Now, the next move is the simplest ratio. What do we mean by simplest ratio? You first identify the least number in your result. What is the least number here? You have 0.17, you have 0.34, you also have 0.17. So 0.17 and 0.17 are the same, right? Now, between 0.17 and 0.34, which is higher? 0.34, which is the least? Or which is lesser? That's 0.17. So which means you are going to use the least one to divide all. Do you understand? So you are going to say 0.17 divided by 0.17, 0.34 divided by 0.17, and 0.17 divided by 0.17. What is your result, please? So this cancels this. You have what? 1. Yes. This is 2. Is it exactly 2? Now, if it is in decimal, you have to approximate to the nearest whole number. So what do you have? 2. And then this is what? 1. So which means the empirical formula for this information now is, or for this analysis, is how many atom? 1. How many hydrogen? 2. Then how many oxygen? 1. So we call this the empirical formula. The next one is molecular formula. But molecular mass has been given. don't mistake molecular mass for molecular formula. Mass is the figure. Formula is what? The structure. Okay, now. It is you having something in brackets. What are you having in brackets? Your empirical formula, if you remember on the table. So you have CH2O, then N. Do you remember? Yes. Good. And everything will give you your what? Your mass number. What is the mass number? Relative molecular mass number of the compound, of the full compound, which has been given to be what? 60. And how do you find relative molecular mass generally? We say if you want to find the relative molecular mass of water, what are you going to say? Since you have H2O, you will say that how many, this hydrogen, the mass number of hydrogen is what? 1. How many atoms? 2. Say 2 plus what? Oxygen is how many? 1 times what? 16. So you say 2 plus what? 16, which is what? 18. Do you understand? So that's the same thing we are doing here. That, what is this? Carbon. So what is the mass number of carbon? 12. So you say 12 plus, don't forget to open your bracket, hydrogen. 1. How many hydrogen do you still have? 1 times 2, then plus what? Oxygen, which is what? 16. Then you close it and you put your N. Everything equals what? 60. Now you evaluate all that you have in your brackets. So now what do you have? 1 times 2 is what? 2. 2 plus 12, 14. 14 plus 16, 30. So you now have 30N equals 60. Are you with me? Very good. Now what will you do to get your N? Of course, you have to divide both sides by what? 30. So you have 30 and then 30. This cancels this. This cancels this. So you have what? 2. So your N is what? 2. So which means we have to put our N back. So N is standing for what? 2. So we have to put it back. And then we say CH2O, then 2. Now, how are we going to write our molecular formula? You expand or open the brackets. Have you copied this? No. Okay. Let me put it somewhere here. So you say the molecular formula is now what? Open the brackets, please. You have C2, H4, and what? O2. This is a representation of a compound, an hydrocarbon compound, which can as well be written as CH4COO. Or CH3COOH. It's an acid. It's an hydrocarbon acid. It's ethanoic acid. Why eth? Because you have 2 atoms of what? Carbon. So ethanoic acid. So this is your true molecular formula. Now, if you don't know how to put it exactly like this, nothing stops you of stopping here. Are you with me? It's not wrong because you are still having the same number of atoms. This is 2, this is 2, this is 4, and this is 2 oxygen. Do you understand? So